Conway's Game of Life, also just known as Life, is a cellular automation game created in 1970 by John Conway, a British mathematician. This game has a few rules that we need to be aware of prior to beginning creating the game. The first rule is any live cell with fewer than 2 live neighbors dies, as if by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. Any live cell with more than 3 live neighbors dies, as if by overpopulation. And then lastly, any dead cell with exactly 3 live neighbors becomes a live cell, as if by reproduction. So we can condense these into the following 3 rules. Any live cell with 2 or 3 live neighbors survives. Any dead cell with 3 live neighbors becomes a live cell, and then all other live cells die in the next generation. Similarly, all other dead cells stay dead. So those are the basic rules for creating the game of life. And so now let's talk about how WebAssembly and Rust and everything just kind of interacts, and some of the things that we need to take into consideration when using Rust to create WebAssembly. So for our game, we are going to create a fixed size periodic universe where cells on the edges have neighbors that wrap around to the other side of the universe. Because neighbors wrap around the edges of the universe, gliders can keep running forever. And one of the first things that what I want to clear up is what wasm-bindgen is. So you can see it here, and you can also see it here in our template. It is a common understanding of how to work with compound structures across this boundary. So it involves boxing Rust structures and wrapping the pointer in a JavaScript class for usability, or indexing into a table of JavaScript objects from Rust. So wasm-bindgen is very convenient, but it does not remove the need to consider our data representation and what values and structures are passed across this boundary. Instead, think of it as a tool for implementing the interface design that we choose. So there are 2 things that we should always be thinking about to optimize. So we want to minimize copying into and out of the WebAssembly linear memory, because unnecessary copies impose unnecessary overhead. And then secondly, we want to minimize serializing and deserializing. Similar to copies, serializing and deserializing also imposes overhead, and often imposes copying as well. If we can pass opaque handles to a data structure instead of serializing it on one side, copying it into some known location in the WebAssembly linear memory, and deserializing it on the other side, we can often reduce a lot of overhead. So wasm-bindgen helps us define and work with opaque handles to JavaScript objects or boxed Rust structures. So in essence, by using wasm-bindgen in this instance, we are exposing the greet function to our JavaScript. And then as a general rule of thumb, a good JavaScript WebAssembly interface design is often one where large, long-lived data structures are implemented as Rust types that live in the WebAssembly linear memory and are exposed to JavaScript as opaque handles, aka using the wasm-bindgen. JavaScript calls exported WebAssembly functions that take these opaque handles, transform their data, perform the heavy computations, query the data, and ultimately return a small, copyable result. By only returning the small result of the computation, we avoid copying and/or serializing everything back and forth between the JavaScript garbage collected heap and the WebAssembly linear memory. So that is just something to take into consideration. It's a very important aspect that I really want you to understand. So if you're still a little iffy on it, please re-watch this lecture again. And then if you have any questions, please ask them in the Q&A section, because knowing when to use this wasm-bindgen is really going to help you organize your code, help you think, far ahead in your project, and it will help speed up your overall the overall performance of your project. So now that we have that in the back of our mind while we're creating our project, let's begin creating our game.